Hello, my name is Murli Bharadwaj and this is my lab. In this lab, I observed and measured the concept of charge in everyday household objects. I applied physics fundamentals including equilibrium, experimental design, and electric force concepts. The primary goal of the lab was to determine the amount of excess charge on a piece of charged tape. In the process, I learned how to induce charge on an object, I observed how charged objects interact with other objects, and I determined the type and amount of charge on an object. The materials included in this lab included clear Scotch tape, two shoe boxes of equal height, a plastic ball pen, a ruler, and a piece of cloth. The lab procedure began with the creation of the U-tape and the base tape. I cut out two pieces of clear Scotch tape and labeled them as base tape and U-tape. I then placed the base tape on the table surface. I created a handle on the U-tape as shown in figure 1 and attached the U-tape to the base tape. I then quickly removed the U-tape by pulling on the handle as shown in figure 2, and then I verified the imparted charge on the U-tape by hanging it from the table and placing my hand close to it as seen in figure 3. The next step of the lab procedure included observing the interaction between two U-tapes. I began by creating two U-tapes, and I observed that when they both interacted with one another, a repulsion was observed. When a U-tape interacted with an uncharged object like my hand or a desk, an attraction was observed. After imparting a negative charge on a plastic pen by rubbing it with a piece of cloth, I observed the U-tape was attracted to that negatively charged pen as well. These interactions indicated to me that the U-tape is positively charged. The next step of the lab procedure was the experimental setup. I placed two shoe boxes close to one another and stuck one end of the U-tape on each box as shown in figure 4. Then I created a second U-tape, and I attempted to float the first U-tape by using the electric force interaction between the two U-tapes as shown in figure 4. I then recorded the distance between the tapes at the moment I observed flotation. During the lab procedure, I observed the velocity of tape B was 0 and not changing, indicating that tape B is at equilibrium. The following free body diagram shows the forces of gravity and electric force acting on the vertical plane of tape B. In order to measure the force due to gravity, I need to calculate the mass of tape B. Before proceeding with calculations, two assumptions were made for simplicity. Both U-tapes have the same net charge, and I treated each tape as a point charge with all its charge at the center of the tape. In order to calculate gravitational force, I measured the length of the tape as being 0.2 meters, and using the conversion factor provided, I determined the mass of the tape as being 0.0002 kilograms. Using the following formula, I then calculated the force due to gravity as being 0.00196 newtons. During the lab procedure, I noted that the separation distance between the two U-tapes was 0.035 meters. Using this and the fact that the U-tape was at equilibrium, I set the magnitude of the electric force equal to the magnitude of the gravitational force, isolated Q, and determined the charge as being 1.6 times 10⁻⁸ coulombs. I then calculated that the number of deficient electrons multiplied by the charge of an electron added to the current charge of the U-tape should be 0. Therefore, the number of deficient electrons in the U-tape should be equal to 1 times 10 to the 11th electrons. Furthermore, the surface area of the B-tape is equal to its length times its width. The area of an atom is equal to its length squared, as given to us in the lab. Therefore, the number of atoms on the side of the tape is equal to the surface area of the B-tape divided by the area of the atom, which is equal to 4 times 10 to the 17th atoms. The ratio of the number of deficient electrons to the number of atoms on the side of the tape is equal to 2.5 times 10 to the -7th. This indicates that very few atoms actually lost electrons. I will now answer some of the lab questions posed. If electrons had a positive charge and protons had a negative charge, there would be no change in the observations made because all the charges would have been flipped and the interactions would be the same. Also, it is important to handle the charged tapes as little as possible because contact can lead to transfer of charge, and this would change the amount of charge on the tape between steps of the lab. For the programming portion of this lab, I used 3 blocks of code shown to define electric field function and graphics, to define and calculate gravitational force, and to calculate charge and electric force. The charge of the U-tape according to my program is 1.633 times 10⁻⁸, and this matches my results.